Okay, in today's section, we're going to be covering linear equations for today and tomorrow. What we're going to be doing here is we're going to be writing and evaluating linear functions using function notation. We're also going to be talking about graphing a linear function and relate the domain of a function to its graph. Okay. In this section, what we're going to be doing, mainly those first one here with evaluating linear functions using function notation. And then at the end here, what I will do is I will demonstrate the steps that we'll need to take on a Desmos calculator if we were asked to create a linear equation from a given linear graph or linear table. Now, first things first is we want to be talking about function notation. Okay, function notation is very similar to slope-intercept form, where slope-intercept form is solve for the y equals mx plus b. Function notation just simply has a function out in front of it. So, for instance, in this one, instead of y, we have f of x, where we use this when we are dealing with more than one function at a time, because otherwise we'd have to put like y sub 1, y sub 2, y sub 3. It's easier just to put like f of x and then change the letters as we go. So we can use f of x. You see down here we have g of x, and on the other examples, you'll see how we use h of x, j of x, and we keep on going from there. Okay. Also, mainly what we use this for is if we're looking for a desired term, like for instance, a specific x value we want to plug in. It's easier to plug it into this one than it is over here because sometimes students will accidentally plug in a desired number at both locations, which will create kind of a, well, straight up, will create the incorrect answer. So let's take a look at one of the examples that we have here, okay, for evaluating functions and function notation. Evaluate the following functions for the desired element. Okay, so the first one they have here is f of x is equal to 3x minus 6. And we want to evaluate that at x is equal to 5. Okay, so what we want to do first is everywhere that we see an x, okay, not only in the equation but also right here, we want to plug in the desired element, which is 5. So we'll have f of 5 is equal to 3 times 5 minus 6. So simply we see here how the x's are now gone and 5's are in their place. From there, we just have to evaluate. So we're going to use PEMDAS to do the multiplication here. 3 times 5 gives us 15. And 15 minus 6 is going to give us the answer of 9. So f of 5 in this, for this function, is going to be 9. Okay? Which basically all we're doing here is substitution. Hopefully it is that easy. But once again, we're going to see how we do with the rest of these. So the next one here, we have g of x is equal to negative 4x plus 5. We want to find the desired element of x equals 6. If you'd like to try this yourselves, go ahead and pause the video and try it. Okay, same thing here. We want to go ahead and for everywhere we see an x, we're going to plug in the 6. So we'll have g of 6 is equal to negative 4 times 6 plus 5. Okay, very similar problem like we had in the previous one. So now we need to distribute here, or we need to multiply here the negative 4 times 6. Gives a negative 24 plus 5. And then from there, do the negative 24 plus 5 to give us a negative 19. Okay. Okay. Once again, hopefully those are some easier examples there. Now we are going to move into some examples that are a little bit more complex because we have fractions, we might have exponents, radicals, more exponents, and some absolute values. Regardless of what they're giving us here, the instructions are exactly the same. Evaluate the following functions for the desired element. Okay? And sometimes they might ask us to find more than one element. So they might say, find it at x equals 45 and x equals 55. In which case, we would just do the process twice. Now you notice here how we have h of x, j of x, k of x, m of x, n of x. Okay? We can use any numbers or any letters in the alphabet. Normally, we don't use some letters. One we don't use is I, simply because we talked about that with imaginary numbers later on in algebra. We might not use L because it looks like a 1. We might not use O because it looks like a 0. Okay, and probably not going to use the letter that we're using for our variable. Because even though we could have f of whatever variable in here, this could be a t, and I could have a bunch of t's throughout this whole process, we would not want to have, for instance, here, we would not want to have x of x. Okay, x of x would be a little confusing to a lot of students, so that's why we tend to use a different letter on the outside, and we prefer the x to be inside. Now the process is still the same in all of these, so once again we're going to have h of 45, plugging in everywhere we see an x. So we end up with 45 over 15 plus 4. Okay. Then from there, we do 45 divided by 15. We'll simplify that to give us a 3 plus 4. And then we're going to end up with 7 for our h of 45 there. Okay. Okay. Very similar to, once again, the last one. Obviously, we just have a fraction here. It's a little bit different with that. Okay. Move on to the next one here. J of x is equal to 3 to the 8th power, or sorry, 3 times 8 to the x power. We want to find out when x is equal to 2. So once again, same thing. J of 2 is equal to 3 times 8 to the power of 2. And we want to make sure we're using PEMDAS, which means we have to do exponents first before we do the multiplication here. So we're going to do 3 times, then we're going to do 8 squared, which is going to give us 64. Okay? And then once we do that little multiplication right there, we should end up with 3 times 64 is 192. Okay, 192 for that one. Always make sure we follow PEMDAS when we're doing these. Okay? All right, the next one here, k of x is equal to negative 2 times the square root of x. We want to evaluate from when x is equal to 196. Same process, plug in 196 everywhere we see an x. So we end up with negative 2 times the square root of 196. Now we are going to treat square roots like parentheses, so we want to go ahead and evaluate this part before we multiply by the negative 2. So we'll still have negative 2 out here, but we want to go ahead and do the square root of 196, which we can use our calculators, which has a little bit of a review right here. To get the square root button, it is behind the x squared button. Okay, so we would have to hit second x squared. Okay, now we hit second x squared of 196, or if we recall this, the square root of 196 is 14. Then we would go ahead and multiply here. So k of 196 is going to be equal to a negative times a positive is a negative. 2 times 14 is 28. So we end up with negative 28 for this given part. Okay. All right, we're going to move down here to m of x now. If you want to pause the video on these two and try them, you can. Okay. Take a look at this right here. Same thing. M of x is equal to 3 times the absolute value of 12 minus x. We want to evaluate it from when x is equal to 30. So let's go ahead and plug that in. M of 30 is equal to 3 absolute value 12 minus 30. Now once again, we want to treat the absolute value like a set of parentheses. So we're going to go ahead and do that first before we multiply by the 3. 3 times the absolute value of 12 minus 30 is negative 18. Now once again, we want to recall that the absolute value basically means what's the distance this number is from 0. You might actually hear it called as absolute distance. It actually is very accurate at what it's meaning, but once again, we are going to refer to this as absolute value. So basically what absolute value means is drop the negative if there is one. Okay? So for instance, negative 18, absolute value of negative 18 will just be a positive 18. But it doesn't mean change the sign. Okay? So if we had the absolute value of 20, it would still remain 20 because we don't change the sign, we just drop the negative if there is one. So here we want to go ahead and do the 3 times 13 for the m of 30, which 3 times 18 is 54. Okay. Moving on to this one here. N of x is equal to negative 3x squared. We want to evaluate that when x is equal to negative 9. Now I'm actually going to add something here, so we're not going to use that function right there. I'm going to change it up here. We're going to do negative 3x squared plus 2x at the same desired value. X is equal to negative 9. So the only difference with here, what I've done is I've added another location for an x. The student asked this today, what if we have multiple x's? The process still doesn't change. Everywhere we see an x, we are going to plug in the desired value. We end up with n of negative 9 is equal to negative 3. There's an x, so we're going to put a negative 9 in there, squared plus 2 times negative 9. And I like going ahead and put every time I plug in a value, it might be helpful for some people to go ahead and put them in parentheses so they know where all the locations are that they've plugged in negative 9. All right, now I do want to bring up something a little bit important here. We notice that we have in parentheses negative 9 and it's being squared. It is best to go ahead and put it into the calculator like it's shown with parentheses, because if I were to simply just do negative 9 squared, that squared is only going to get applied to the number rather than the sign and the number. That's why it gives us a negative 81 for this. Because remember, when we square a number, we're doing a number times itself, so it should always be positive. So when you don't put the parentheses in, it's giving us a negative, or it's not doing the negative times negative, it's just leaving that negative out front. So always remember, now if you're able to recall, okay, if I do negative times negative, it's a positive, and you just want to focus on 9 squared, that's good too, because 9 squared is going to give us the correct answer there of 81. Then we have 2 times negative 9 here, that's a positive times a negative, so that's a negative. 2 times 9 is 18. Okay. Now we got a couple more steps here, so we have negative 3 times 81, which is negative 243. This will be, and actually guys, for those of you that are trying to copy down your notes, I didn't do this with my classes today. Okay, this was just an additional question we had students ask. So the original one that we had, where we were just trying to do negative 3x squared, okay, that would be all the work we would need right there. Okay, so that's still the 3x squared, the negative 3x squared that we're dealing with. So that was the final answer that we had today. Okay, for our notes, negative 243. I'm just showing you how we are going to do it if we have more than one x location. Okay, so here, for instance, I would need to take that and subtract 19 or subtract 18 from that, and that would give us a negative and a negative. Actually, keeps it a negative. We're just going to go and combine these numbers to give us a negative 261. Okay. Once again, I stretched that example off a little bit because I want you to understand that even though we could have 5 places with those x's, we would just plug in negative 9 for everywhere that we see an x. Now for the last example here, in class we were able to use the Desmos calculator to show this a little bit better. So if you have any questions over this, make sure you come in during one of the open periods and I can show you how we do it on Desmos calculator. But what they're asking for us in these ones is they give us 2 linear functions, okay? But they're in table form. They're asking for us to write the equation. Now, before, what we'd have to do is we'd have to select 2 points, then find the slope, then take the slope at a point and put it in point slope form, then distribute the slope, then get the y by itself, and then we'd have our equation in slope intercept form. But using the Desmos calculator, this process is going to be a lot easier. Okay? The first step is just to simply enter in our table. Okay? All right? Enter in our table, which we have to hit the plus button at the top left of our screen. Okay? But then we'll see if we hit the plus button, you'll see where it says enter table. We can just enter in our table as we need to. The second thing, we want to write in a new equation. Okay? A new equation. Now that new equation is going to be right where I'm about to type in. y1, which you simply just need to hit y, then the 1 to give you y1. Now this squiggle here, we actually get this symbol here by holding down the shift and then pressing the button that's underneath the escape in the top left-hand corner, or it's to the left of the 1 button, okay? You want to real quick, I'll show you, I can with this. That is the button we're looking for. So if I hold shift and hit this button, it'll give me that squiggle that we need there, okay? So just want to make sure we understood that location there before we move any further. Give me a second here to get this back where I need it to be. Okay? Y minus y sub 1. Now the rest of it's kind of like our slope intercept equation. It's y is equal to mx plus b. But just like here before we had to have y1, here we're going to have x1 plus b. And actually we enter this in exactly like it's shown. Okay? Now when we do that, it's going to give us an r squared, an r value, and then at the very bottom is going to have an m equals 2 and a b equal to. Okay? Since we're dealing with linear equations, both of these numbers are going to be 1s. If they're not 1s, then we don't have a linear equation with the values that we plugged in. So for the 2 examples that we have here, both of these will end up being 1s. Okay? Then for the 2 that we have here, we see at the bottom that we have 3 for the m and negative 2 for the b. Now, by simply entering in this table in the Desmos and then hitting a new equation and typing this in, it gives us the slope and the y-intercept. Okay? Which means we can just simply plug this in to y equals mx plus b form, where the m is 3, so we're going to have y is equal to 3x plus b. Now, since we have plus and negative 2, we're going to end up with a minus 2 right there. Okay? That is actually the answer that we're looking for. Now, in the instructions, they do say write a linear function, so if they wanted us to put it in f of x form instead, reminder, it's the exact same equation, just without the y. Okay, either one of those two is good, but if they do say function form, we're probably going to be looking at that one. Okay. Now we're going to follow those same instructions for this one here, just typing in the different values. So once again, we have to enter the table. 2, we want to enter the equation y1. Now I do refer to this as the similar, okay, because we use this in geometry when we talk about similar figures. It's a squiggly line, okay. So y sub 1 is squiggle to mx sub 1 plus b. Once again, entering in that equation, it's going to give us these r values being 1, and then it's going to give us m is equal to 6.5, and the b is equal to 0. So once again, it does all the math for us, where we don't have to calculate the slope and then put it into the correct form, and then put it into point slope form and then put it into slope intercept form. It did all the math for us, where we can just plug it into y equals mx plus b. Now for this one's a little bit different, because we're going to have y is equal to our slope, 6.5x, and that's actually going to be it, because we're going to have a 0 for our y-intercept, so we could put plus 0 at the end, or we can just leave it like that. Because remember, anytime we don't see plus or minus any number at the end here, we know that this graph is going through the origin. And once again, as a function notation, even if I use a different letter here, like t of x, okay, t of x now, it's still going to be the exact same equation. The only difference is the little part at the beginning. Okay. Once again, this is a little bit easier when we have the Desmos calculator in front of us. I was unfortunately not able to put that on the screen here because there was a little technical difficulties. But once again, all we have to do is, from the Desmos, we enter the table because there's a plus button in the top left-hand corner. We hit that and hit table. Plug in the table there exactly like it's shown. Type in this equation exactly like it is right here, and it's going to output the desired values of 3 and -2 for our slope, or for our slope and y-intercept respectively for this one, and then the slope and the y-intercept for that one. Once again, if you need to see me do this with you, go ahead and make sure you come in during one of the open periods. Make sure we complete the assignment for this section, because that will conclude this section. And as always, if you do have any questions, send me an email.